Thank you for watching my presentation for the Norfolk Coast Dark Skies Festival, Weather Under the Dark Skies of Norfolk. I'm going to split this talk into three parts. I'm going to start off by telling you a little bit about what makes Norfolk such a challenging place for weather forecasting, what makes it unique in that regard, and then I'm also going to tell you a little bit about the science behind weather forecasting in 2020, maybe compared to what it was like a few decades ago. And then the second part of the talk, I'm going to tell you a little bit about where to go to get a weather forecast and why mobile phone apps might not always be the best place to do that. And then I'm going to finish up by showing you some of my pictures. I'm by no means a professional photographer, but I do like to get out there and take photos of the Norfolk sky, particularly night skies, and have done that for a few years now. So I'll share with you some of my favorite pictures and things that I like to photograph in the sky in Norfolk. And this picture you're looking at here was one that I took back in the middle of the summer, July 11th, 2020, from Saul, Norfolk. And this is obviously Comet Neowise. I'm sure most of you watching were able to get out and see the comet. It was visible by the naked eye for a couple of weeks across the county this summer. Beautiful sight, and funnily enough, this picture was only the second photo I took on my camera of the comet throughout the whole 2 or 3 week period that I went out and did that, and ended up being one of my favorite shots. So I'll show you a few more that I took of Comet Neowise toward the end of the talk. So before we go any further, I'll tell you a little bit about myself. I'm a weather forecaster for a company called Weatherquest that's based at the University of East Anglia in Norwich. I'm one of the directors of the company as well. And then alongside that, I also lecture in meteorology at the University of East Anglia. So if you want to get in touch with me, I'll be happy to answer questions about this talk on Twitter at Stormbell, but you could also find my email address on the Weatherquest website, and feel free to email me questions there as well. I'll share the website with you a little bit later in the talk. But also, I give talks to other groups around the community as well, so if you're interested in me giving a talk, feel free to get in touch, and hopefully we can arrange that either in person sometime in the future or virtually like this talk. I'll just say something quickly about the picture you're looking at the moment. So that's a photo that I took back in 2012 just south of Dallas, Texas. So growing up, I wanted to be a weatherman from a very early age. I went off and studied it at university, and then while I was at university, I became a storm chaser for several years. I would go out to the Great Plains of the United States in search of some of the biggest thunderstorms in the world, and it produced one of them that we were watching produced one of these this picture that you're looking at here of a very bright lightning strike only about a mile or so away. Some very loud thunder associated with that, as you might imagine. Right, so getting into the talk now. Norfolk, a challenging place to forecast. Well, there's a couple of reasons why, really. It starts with the geography, and then it's also the science of the atmosphere of the Earth that make Norfolk particularly challenging. So to start with, the geography, we're sitting on the edge of a big ocean off to our west, the Atlantic Ocean, and then the continent of Europe off to our east. And so sitting on that boundary between an ocean and a continent can have some big impacts on the air masses that affect the UK and particularly eastern parts of England, and that can bring about some very large swings in weather depending on what direction the wind is blowing from and what time of year that you're in. So I thought what I would do is just tell you a little bit about the air masses that do affect us here in the UK. So the Met Office has done a really nice, the UK Met Office has done a really nice schematic showing the 6 main air masses that affect the UK. I'm going to start off on the western side of the UK here. These are our most common air masses that affect the UK. We'll start off down here with the tropical maritime air mass. That air originates from the middle of the Atlantic and it comes up into Britain on a southwesterly. It often brings with it warm, moist air and oftentimes showery weather as well, brought about by the low pressure systems that come in from the west. And then if we get winds a bit more from the west or the northwest, that's your polar maritime air masses, and actually the combination of these two are the most common air masses that we see across the British Isles. They often bring cool and unstable weather with them, often bringing rain and showers with them, but with some sunshine in between as well, and they can be quite chilly, particularly in wintertime. And then another air mass that we get, this is where we see our big temperatures in the summertime, the tropical continental air mass. That originates out of North Africa, the Mediterranean, southern parts of Europe. If you get a southerly wind blowing the tropical continental air up over the UK, you can get temperatures into the 30-degree range during the summer. So our hot days in summer usually are thanks to the tropical continental air mass moving in over the UK. And then moving up the graphic here, the polar continental air mass, that's air that streams in from Central Europe or even Western Russia, southern Scandinavia as well. And this brings relatively warm weather in the summertime, but this is where our cold weather comes from in winter. And so the beast from the east, you'll remember from a few years ago, was a polar continental air mass that came all the way out of Western Russia into eastern Britain and brought us quite a bit of snow. So as that air mass moves over the North Sea, it picks up moisture at the bottom of it, and that gets deposited as snow in winter months. And then the least common air mass that gets into the UK is the Arctic maritime air mass. That comes from the north and often brings with it some very cold bouts of weather, but also because it's originating over the Arctic Sea and the North Sea to the north of Britain, it will bring quite a few snow showers with it as well. And one of my favorite types of weather happens under the Arctic maritime air mass, and that's showers that produce nothing but snow, but also lightning as well. So a thunder snow shower. I've seen it one time here in Norfolk, and that was back in 2005, so quite a fun weather event to get to look at. So one of the things that you always hear to blame for the weather is the jet stream. So I just thought I would say a little bit of something about the jet stream as well. The jet stream is a very fast flowing bit of air that's quite high up in the atmosphere, about 30,000 feet above the earth, about the height in which jet aircrafts fly at. And that usually steers weather systems along it as it moves through. And it just so happens that Britain, sitting on the edge of the continent and the ocean, also sits high enough in latitude to be underneath the average position of the jet stream through various times of the year. And so the jet stream steers lots of weather systems off the Atlantic Ocean into Britain. It does bring us relatively mild weather for where we are in latitude, but it can also bring us windy and changeable weather on and off. And that's particularly the case when the jet stream is more west to east oriented in a sort of line. You get round after round of these areas of low pressure coming through. When the jet stream does what you're seeing on the chart here and is more wavy, we call that a meridional jet stream, and often that will bring with it weather that stays the same for several days in a row. And I'll return back to that theme a little bit later in the talk too, when I talk about how reliable a weather forecast can be. So what are some of the challenges of forecasting in Norfolk? Well, I haven't put a lot of text on my slides. Most of them are just pictures and images and graphs and that sort of thing, but I am going to spend this one slide just putting up some text just to highlight some of the weather events that we see here in Norfolk and what causes them. So the first I want to highlight is when we get warm, humid air flowing over a cool sea. And that will develop low stratocumulus cloud as well as the potential for some sea mist and fog. And this is particularly the case in Norfolk in the late spring and early summer. And the reason for that is that it takes a little while for the water to warm up around the British Isles after winter. The land will start to warm up a little bit more, so you'll start to bring in some warm humid air from the continent out over that cooler North Sea, and it generates quite a wide area of stratocumulus cloud and can produce sea mist and fog as well, and that particularly happens in the late spring and early summer. Another thing that will happen in Norfolk quite regularly is you get hot, humid weather in the summer coming up on a southerly flow, and this can bring with it thunderstorms from the continent. Sometimes they'll only skirt up along the east coast or just offshore, and it's quite nice when that happens because you can take the camera out to the east coast of Norfolk at night and you can see the lightning flashing away out over the North Sea, and that's one of my favorite things to do. And if you get really lucky, sometimes the thunderstorms come right up over Norfolk as well, and nighttime lightning is really fun to take pictures of because it's a lot easier to get lightning on camera at night than it is during the daytime because you can just leave that shutter open of the camera lens and wait for a lightning strike. Another thing you can see in Norfolk is a north or northeasterly wind flow, and that will bring with it those sea-driven wintry showers in the wintertime. So as the air flows over that relatively warm sea in early winter, that can generate some big showers, quite a lot of sleet or hail in them, and even some snow if it's cold enough as well. So we often see that in the first half of winter, especially when the seas are a little bit warmer. And light winds in autumn and winter, so we're entering that time of the year at the moment. So if you get light winds and clear skies, that will allow your shallow mist and fog patches to develop inland. So if you're going to go out and take pictures or look at the night sky, sometimes that can be scuppered by mist and fog patches around the county. So it's always worth just keeping an eye out. And if you've got clear skies, light winds, just checking the forecast to see if fog is going to be very widespread. And that tends to happen when that happens in kind of river valleys and dips and that sort of thing around the county, more so than it would up on the cliffs, say in North Norfolk. In the summertime, we get sea breeze effects as well. So as the land warms up during the day, it rises, and then the air rather from over the sea will move in to replace that air that's risen, and it will bring us cooler and more humid air off the sea, and that will affect the visibility as well, and that pushes back offshore during the evening and overnight. So that can make things a little bit tricky for forecasting too, and just occasionally sea breezes can generate some scattered showers or even a thunderstorm in the summertime. And then the last thing I'll mention is that our heaviest rain we get in Norfolk normally happens on a northeasterly wind, and that's because areas of low pressure that pass to the south of Norfolk, maybe across southern England, the air flowing around them in a counterclockwise fashion will bring the winds in from the northeast. And what's to the northeast of Norfolk? Nothing but water, so it's just a constant feed of moisture coming into the county, bringing us quite a lot of rain. And almost every time you see rain of more than an inch or two in the county over a couple of day period, it's in a persistent northeasterly wind as low pressure moves to the south of Norfolk. That's it for the text-heavy slides. We'll move on to some pictures and graphs and that sort of thing from here on out. But I just wanted to talk a little bit about how we put together a weather forecast nowadays. And before I do that, though, I'll say that no weather forecast is possible without observations. So the first thing you have to do if you're going to get a weather forecast right is you have to make accurate observations of what's happening now. And there's lots of different ways to do that. You can see on this this image here, you can do it from ships, you can do it from oil rigs, you can do it from different ground stations and weather balloons, radiosondes. That's what we call the package attached to a weather balloon. Aircraft, as they fly around the Earth, will make measurements too. Increasingly nowadays, we're using satellites to look down on the Earth and measure the atmosphere, and a lot of our weather observations come from those. And the more traditional way of doing it from a manned weather station. And I've just got a picture here that I took a couple of summers ago of the official Met Office weather station at Weybourne in Norfolk. So some of you might have seen this on your walks through Weybourne or up on the North Norfolk coast. But what you've got here is what we call the enclosure. So this is the Met Office weather station there. Lots of different instruments scattered about on this little patch of land. You can see the tall mast here. At the top of that is the anemometer, where we measure wind. That has to be done at 10 meters above ground level, so hence why the mast is so high above the ground. Some various other things going on here. I'll just point your attention to this thing because I'll zoom in on that in just a minute and tell you a little bit about it. This little column standing up here. And then you can also see the more traditional, what we call Stevenson screen. And inside that Stevenson screen is where we measure the temperature and the humidity. So I thought we're talking about night skies in Norfolk and enjoying the stars and that sort of thing, but oftentimes that can be clouded over. And so I just thought I would tell you a little bit about how we make cloud observations in weather forecast for weather forecasting purposes. And there's three elements to it, really. The first is using human observers to go out and have a look at the sky and determine whether there's low, medium, or high level cloud and what types of cloud there might be around. Is it stratus cloud? Is it cumulus cloud? Is it cirrus cloud? That sort of thing. And then we have to talk about how much cloud is in the sky. So we actually measure the amount of cloud in the sky in what we call octas. and that splits the sky up into 8 sections basically. And so if you had a completely cloudy sky, you would have 8/8 cover of cloud. If you had clear skies, you would have 0/8 cover of cloud. And if it was a partly cloudy day, sort of 50-50, 4/8 cover of cloud. But nowadays we use this little column, this white box here, and it shoots a laser up and measures the cloud base by the scattering of the laser, and so we can use that to measure how high the cloud is above the ground. Particularly useful at airports where they want to know where the cloud base is and that sort of thing. But I thought I would show it to you because one of my colleagues at Weatherquest, Dan Hollies, made a nice little cloud climatology for Wayborn. So looking at that LiDAR that I was showing you in the picture from Wayborn there, what we've done is we've taken the last 5 years worth of data, every hour of the day, every month of the year, and we've looked at how what the average cloud cover is for that time period. And this is particularly looking at low cloud, but what you will see is something quite noticeable here. You can see if you look down into the months of August, September, October, and November, that's the lighter shading in the graph. So the whiter colors are clearer skies, and the red colors are more cloud. And so if you want to get out and take photos at night and you want to have the best chance for clear skies, then you're looking at the first part of the graph here, midnight to 3 a.m. And sort of the evening hours, and you can see that the lighter shades on the graph there are showing up during the months for late summer and into autumn. So that's the best time really to get clear skies out across the county. And you can see the problem I was talking about earlier with the cool seas around Norfolk and bringing in any warmer air over the top of them. You tend to get a lot of stratocumulus cloud, and that tends to be a real factor at the end of winter and through the spring months around the county, making it a bit more cloudy on average that time of year. One other thing that can cause you problems if you're going out and taking pictures, as I mentioned earlier, or observing the night sky, is the visibility. So I just thought I would show you how we measure visibility in meteorology. So basically what's happening is you shoot a laser from one side of this instrument to the other. It measures the amount of scattering of that laser, and it can tell what the visibility is in kilometers. So it does a calculation to know if that moisture there is scattered that much of the laser, then to the human eye you'd be able to see this distance into the out across the airfield or wherever you were looking. So that's how we measure visibility. This picture of this visibility meter was taken at Watersham down in Suffolk. So I went down there with a group of students and took the picture. So fog is a challenge across the county, and again, because we're surrounded by water on our northern and eastern coasts, this satellite image here, a picture from space, all the white you see in here is this low stratocumulus cloud and fog out in the North Sea, and it can be very dramatic to what it looks like on shore versus offshore. So this is a picture showing decent visibility along the coast. You can see quite a ways down the coast there in that picture on the top picture in the left, and then just offshore the ships are very hardly visible if you look out across the sea. So that can present some challenges, and depending on the wind direction, that will push the fog inland or offshore, causing problems for seeing the night sky, for example, if you were out overnight. So all these observations I've talked about, they get put into a supercomputer nowadays, and this is how we do weather forecasting. So all the observations that we see taken get turned into mathematical equations and then put into some of the fastest computers in the world in order to generate a weather forecast. And this is much different to how it used to be maybe 40 or 50 years ago before the supercomputer, where a human would draw up a weather chart, they would draw the isobars on the chart, and then they would do it again the next hour and the next hour, and they would look at how the weather was progressing, and then they would try to make a forecast. And if they could do that for a day or two in advance, they would be pretty proud of themselves in those days. But now the computer can take so much information and turn it into all these different equations. It knows where the temperature is in any given location that we have measurements for. It knows the wind speed and direction, and those equations can project what it would be the next hour, and then the next hour, and then the next hour, and it can go out. And nowadays you can get weather forecasts that go out a whole few months in advance. But I'll talk a little bit about what you can rely on from a weather forecast in the next couple of slides. But that's how it's done nowadays. So this is what I spend my day looking at mostly. These are weather charts generated by a supercomputer, computer model. So the top left image here is showing you cloud and rain and isobars. The top right image is showing you the temperature across Europe. The bottom left image is showing you the visibility, so the orange, the yellow and orangey colors on the map here are showing you low visibility, and then on the bottom right your wind speed and direction. So you can see on this particular chart quite windy across northwest Scotland, light winds over the continent. But there are lots of different forecast supercomputers. So agencies all over the world are running their own supercomputers with just slightly different equations in some of them, slightly different sets of observations, and slightly different ways they go about estimating what the weather is like in between the observations to go into the supercomputer. And what that does is it introduces uncertainty when you do that. And so as you project the forecast further into the future, these supercomputers can have a different forecast. So this is 4 different computer models here from 4 different agencies showing the same time, and you can see they're all slightly different. So obviously there is some uncertainty in the forecast when that's the case. But when does that uncertainty creep into the forecast? That depends on the weather situation, and I'll say a little bit more about that over the next couple of slides. So in the short range, generally these computer models are in pretty good agreement. So just ignore the sort of bottom of this image for the moment. Just look at the top 2 images here. The greens and the blues are showing you rain. And the model on the top left is a model run by a group of European countries, including the UK. And the top right image is a model run by the Americans. And so this forecast is for a day and a half in advance, showing rain moving across northern England, northwest parts of Wales. And in both models, the pattern of the rain is pretty similar. You can see there are some differences if you cast your eye back and forth between the two, but in general, the pattern is pretty similar between the two. Now what I'm going to show you next is what happens 7 days in advance. So it's the same computer model run that was in pretty good agreement at a day and a half in advance, but when we look out 7 days in advance, those computer models are drastically different. So for example, if let's say you had a holiday or a weekend booked to go up to Cumbria to do some fell walking, well, this European model would tell you that it's going to be a sort of dry situation with a northwesterly wind, probably quite chilly. But the American model is showing a keen southwesterly wind and a very wet weekend with potentially an inch of rain in a 6-hour period across Cumbria. So some point between a day and a half and 7 days in advance, those two forecasts differed quite a bit, and that's the role of the weather forecaster nowadays. The role of the weather forecaster is to understand which models handle which weather situations the best. Sometimes a computer model might be better at nights when it's clear with light winds, and other models might be better when the weather pattern is more breezy and cloudy and unsettled. So that's where we make our money these days, if you will. As a weather forecaster, we analyze lots of different computer models and know how to use each one in which weather situation. So one of the questions I get asked all the time is, how far in advance can you forecast the weather for? That really depends on the weather situation, and that is going to be demonstrated in the next couple of slides, where I'll tell you about a couple of common patterns we get in the British Isles here and how that affects the forecastability of the weather, if you will. So in this situation, we have a mobile Atlantic southwesterly. So what we're looking at on this weather chart here is an area of low pressure to the north of the UK, with the air spinning around it in a counterclockwise fashion. With some higher pressure down to the south. and that's helping to feed the air in off the Atlantic Ocean. When you get that situation, you get areas of low pressure sort of riding in between these boundaries here and bringing air in from the southwest, and over the course of a few days you'll get several lows coming in, and after you get 3 or 4 days in advance, the timing on an area of low pressure becomes quite uncertain, and so it can mean that 4 days in advance you're looking at a dry day, but then on the 5th day an area of low pressure is going to come in, and over time the timings of that can change by 12 hours or 24 hours, and it can make the forecast pretty challenging. So we'll know that it's going to be an unsettled pattern, but we have trouble pinning down exactly when the rain will come in. And so a forecast in that type of weather pattern past about 3 days is going to be pretty difficult. Now contrast that with what we call a blocking pattern. And this is where we would have an area of high pressure sitting near the UK. And in this case, on this weather chart, we've got high pressure to the northwest of the UK and the air flowing around that in a clockwise fashion. And so in this case, it's bringing air that's a bit from the north down across the UK, probably slightly cooler air. But what these high pressures tend to do is they tend to block any weather systems coming in through them. It takes quite a long time for them to be shifted from where they are. And so if you get a blocking high set up near the British Isles, it can often bring similar weather for several days in a row, and in some cases maybe even a couple of weeks at one time. And there have been instances in the past where we've seen these blocking highs develop. The computer models are fairly certain that they're going to hang around for a while, and you can be pretty confident in a forecast 10 days in advance. So when someone asks me how far we can forecast out, I generally return the question, well, you need to tell me what kind of weather pattern we're in, and then I can give you an idea of how far out I can give you a forecast for. So it can vary between as little as a day or two in advance to as much as 2 weeks in advance in that situation. I also mentioned at the beginning that I was going to tell you a little bit about weather apps, and this is another helpful tip from my colleague Dan Hawley that I mentioned earlier, but the pitfalls of using weather apps. And this is just an example of why it can be tricky to use a weather app when it comes to forecasting rain, particularly in showery situations. So what you're looking at here is a computer model forecast on the left and a weather radar observation on the right, and just pay attention to points A and B here. So if you were at point A, your forecast model would be telling you that it was going to be a dry day, so your app would be telling you that at that particular time it was going to be dry. But you can see that at that time there was a shower on the radar right over point A. At point B, your forecast model is telling you it's going to be wet. It's got this cluster of showers in here that are actually pretty well forecast, but the problem is just not right over where B is. So as a weather forecaster, I would say this model has actually done a pretty good job of forecasting the weather for that particular hour, but you can see it's not quite in exactly the right location, and that will be a problem for weather apps because they will be looking at your point location and not necessarily 20 or 30 miles away to give you an idea of how the weather might be changing from one location to the next. So can be a bit tricky really using these weather apps, and you really need to, especially in showery situations, have an understanding of how widespread showers might be, or use a weather radar to kind of help you on the day see where the showers are and where they're developing, and I'll show you a little bit more about that in just a second. So the last part of the, or second part of the presentation, I'll go a little bit quicker through this, is how can Weatherquest help when it comes to forecasting the weather and making a decision on whether you're going to go out and have a look at the night sky across Norfolk. Well, the first thing you can do is follow us for free on social media, on Facebook or on Twitter. So on Facebook we're at /Weatherquest, and on Twitter we're at @Weatherquest_UK. Twice a day, every day of the year, we post a weather summary for East Anglia, a little weather forecast for the coming night or the coming day. So in the evening we'll tweet out a forecast for the night, and in the morning we'll tweet out a forecast for the coming day that tells you about what weather is expected across East Anglia, what direction the winds are coming from, and what your high or low temperature is going to be for that coming day or night. So if just get that for free if you follow us on the social media. You can also listen to us. So on our website, weatherquest.co.uk, we do a free daily audio podcast. So you can go to the services tab on the Weatherquest website, click on audio podcasts, and you can listen to our East Anglia forecast, anywhere from about a minute to 2.5 minutes long. But one of our trained weather forecasters sits down every morning about 7 to 8 a.m. and records a podcast and puts it on the website so you can listen to a weather forecast. And there you get to talk a little bit more about the uncertainties of what the weather might be on a particular day. And we generally give a 2 or 3 day forecast in the audio podcast. If you want to spend some money, let's say you've got an important event, a wedding, or maybe you're a photographer that does shoots photographs for weddings, or maybe you've got some sort of commission to do for night sky photography, for example, and you need to make a business decision. You can speak to one of our trained weather forecasters on the phone and talk through the weather forecast. And this is mainly used by farmers across the region and that sort of thing. But you can ring us on 09065 777675. That's answered between 6 a.m. and 6 p.m. every single day of the year, and the calls are charged at £1.55 per minute, plus any network charges you might have on your mobile phone. But there, as I say, you can ask a forecaster questions, and we can talk to you about the uncertainty and maybe give you some advice about how the weather's looking over the next few days. And that sort of thing. So feel free to give us a ring on that if you've got anything that's going to be high stakes riding on it. Most of the phone calls 2 or 3 minutes long, so you only spend £4 or £5 at the most. If you want to track weather radar, there are some free weather radar apps out there, but we offer weather radar through our product called wqradar.co.uk. If you use the promo code RADAR, you can subscribe for £25 per year. We charge £25 a year because we not only give you live radar, but we also include lightning with that, and we also give you the ability to go back and look at historical data and also weather observations from around the region. So you can click on the map and get weather observations from your closest official weather station. In this case, I've screenshot one from Weybourne in Norfolk to show you what the weather was like at that particular hour, and you can see the air temperature, max temperature, that sort of thing. But weather radar tracks real-time rainfall, and you can put it in an animation and you can see where it's moving. And if you're going to be heading out and you want to know if you're going to get wet in the next couple of hours, weather radar is a great thing to have a look at to see if you're going to get wet in the short term in terms of a forecast. You can also track lightning as well on that. So again, for night sky photography, for taking pictures of lightning strikes, it's quite nice to be able to see where they're occurring and whether they're moving towards you, and you can get that on WQ radar as well. Right, you've listened to me drone on about the weather for long enough now, so I'm going to finish the talk here by showing you a few of my favorite pictures that I've taken. As I say, I'm not a professional photographer, but I do love to go out and take pictures with my camera across Norfolk, and particularly at night. So we'll start off from a picture I took this summer, the 21st of July, across North Norfolk, and this is just the Milky Way. So one of the fantastic things about living in Norfolk is the dark skies that we have, which is why you're all listening to this talk, and being able to go outside in your back garden and look up and actually see the cloudiness of the Milky Way. So many people on the earth don't have the opportunity to see that, and it's such a great opportunity to be able to do that in Norfolk. And I love once or twice a year going out and taking pictures of the Milky Way. And just in case you don't know, the Milky Way is usually best seen toward the end of summer and into early autumn, because you can see the bottom of it down here where it kind of splits off and has the bits of cloudier tinge to it. So it tends to be best for photography sort of late summer, but it does mean you have to stay up quite late to get pictures of it. Noctilucent cloud, they're one of my favorite things you can see in Norfolk. For about a month around the summer solstice, so we're talking about from mid-May through mid-July, If you look on the northern horizon in the evening and it's clear, and you can see a bit of a tinge of color or what looks like wispy cloud on the northern horizon well after dark, close to midnight, 11 p.m. midnight, when the sun is well below the horizon, it will shine up on occasionally on these noctilucent cloud, which happen about 50 miles above the Earth's surface in the stratosphere. They're the highest clouds in the Earth's atmosphere, and there wasn't a lot known about these clouds until probably about 20 years ago, and it comes to find out that most of these clouds are formed by dust from meteors that coming into the Earth's atmosphere, and increasingly rocket exhaust as we launch satellites into space. So they're very pretty to look at, lots of detail in them. This is a zoomed in image from this summer of the noctilucent cloud just down the road from my house, but you can see all the intricate detail in the cloud there, and they kind of float around and disappear quite quickly, but they're quite fun to look at. The aurora borealis. Believe it or not, it can be seen from Norfolk occasionally. This was the best display I've ever seen of the aurora in Norfolk since I've lived here. And I moved here in 2004, and this was in 2014. It was visible to the naked eye. What I will say, though, is the aurora is picked up on camera much more vividly than it is to the naked eye. And I have a friend, I think, who's giving a talk as part of the festival as well, James Raleigh Hill. He'll talk a lot more about aurora and noctilucent cloud and show you a lot more pictures as well. So I won't give the game away, but in this case, you could see the red tinge in the sky to the aurora, and you could also see the sort of pale greenish white glow, and occasionally some of these beams sticking up into the sky as well. So aurora, very pretty to look at. Another image from that night. Again, the camera, if you leave the shutter open for 10 or 15 seconds, really pops the color out. It wasn't as bright as that to the naked eye, but still a very fun event to have a look at. And just down the road from my house as well. Another one that I took back in 2015, that's me in the foreground there pointing up at the aurora, a much more diffuse aurora on that occasion. This is more typical for what I would call a decent aurora for camera for Norfolk, but you can see still quite bright to the camera, and that would have been pretty hard to see to the naked eye, that picture there in real time. This is one of my favorite pictures I've taken of the aurora from Norfolk because of the time of the year. So I took this picture on the 16th of July, and the reason why this is one of my favorite pictures is because you've only got an hour or two of dark to play with in the summertime. So being able to get a picture of the aurora in that really fine window of only a couple of hours in the middle of summer was a great challenge, and it was kind of early in my photography career, so you can see that it's a bit of a grainy image, but still one of my favorite pictures that I've taken. A couple of pictures of Comet Neowise from this past summer as well. So that's my boy in the foreground there pointing up at the comet. Really awesome to be able to take him out to see a comet. Don't get many that bright in the sky. So you have to take your opportunities to see them when you can. This is Neowise with Baconsthorpe Castle in the foreground. So Baconsthorpe Castle near Holt in Norfolk. Had to go up there, and we shined a little bit of foreground light on it just to bring it out in the picture. It was quite a misty, foggy evening, unfortunately, so that made taking pictures of the comet quite difficult from there. But I still thought that was quite a pretty one. Another one, as the sun was rising, so this was 3 o'clock in the morning on the 13th of July from Thimblethorpe. Actually, sorry, not Thimblethorpe, that's incorrect on the slide there. That's actually Weston Longville, where you get the big wind turbines near the A47, just to the west of Norwich, and that's Comet Neowise over the top of a spinning wind turbine. About a 3 second, well, it's probably about half a second to 1 second exposure on that picture there, because you can see the blades haven't moved very far. And then this was just kind of a fun shot. There was a car coming down the road with the headlights shining on the tree, bringing it out in the foreground, and I also kind of drew the lines on the plow there so you could see where it was relative to Comet Neowise. So kind of fun to take that image as well. And then another image that you can get in the night sky nowadays, all the satellites floating around above space, and even the International Space Station. So this was one picture that I took, a 14-second time lapse of the International Space Station moving across the sky, but also Elon Musk's Starlink satellites. There's quite a lot of them. I know there's a lot of controversy about night sky pollution with those, because there's so many flying around now, and you can see even in this one image there were 4 satellites moving across the picture here along with the International Space Station, but still kind of interesting to get a picture of those as well. And then finally, I like to go out occasionally and just take a picture really for memory more than anything else, of planetary alignments. So in this case, you've got Venus, Saturn, and Mars all in one shot, and that was taken from Swanton Morley in Norfolk back in 2016. So I won't go on any further. Thank you very much for listening. I know I've probably gone well over time. I just wanted to leave you with a few free weather websites that you can visit alongside the Weatherquest information that I told you about. The UK Met Office do a really good job of writing some text forecasts for East Anglia. That's quite useful for planning any outings that you might have in the evening and overnight, so would recommend that website. XC Weather do a good job of weather observations, telling you the real-time temperatures and wind speeds and cloud cover, so that's another good website to visit. And finally, if you're wanting to dig a little bit deeper into weather forecasting and look at some of these computer models, Windy Weather is one of my favorites, very pretty to look at as well. They've done a nice job of visualizing computer model data, so check that out if you're interested in the computer model forecasting side of things. Once again, thank you very much for listening, and I hope you enjoy the rest of the talks as well.